Dear friends, we are coming to the next lecture, that is polynomial addition. So let's look at these two polynomial, the same polynomial that we saw previously creating. So we have polynomial P1 and polynomial P2. We have the addition, which is the third polynomial P3. Here of course when we add, we know if the powers are equal, they are added. For example, 2x to the power 4, we don't have a power 4 term here, so plus 4x3 plus, here the powers are same, x square, so 5 plus 2, 7x3. Now this is a possibility, plus minus. So what happened is powers are equal, so they are added, but since the coefficients are the complement, they get reduced. So this becomes 0x, that we need not to add, so that term is removed. 2 plus 1, 3. So meaning if the coefficients become 0, that term need not be in the polynomial, resultant polynomial. So this is the result of P1 plus P2. I think that's clear. Now let us see how they are represented as linked list. So we have the entire polynomial represented here. So this is your P1 and this is P2, and finally we have P3 added. Now P1 we saw 2x to the power 4, 5x to the power 2, 3x to the power 1, 1 power 0, 4 to the power 3, 2 to the power 2, 3 minus 3 to the power 1, and 2 to the power, this should be 0 not 4, it's a small mistake, this should be 4 0, that's fine. Okay, and here the resultant polynomial. So if you look, this is a polynomial to the power 4, 4 to the power 3, 7 to the power 2, 3 to the power 0. So that is, now let's see how we are going to do the addition of a linked list. So I think this much is clear. So this is P1, this is P2, P1, P2, P3. So let's see how. So initially when we start, just like any linked list program, this is almost like merging two linked list. Okay, have a concept in your mind. So we are going to say, while both are not over, both a list, so P1, P2 not over, so pointer is going to be here. We are going to start, the representation is from higher power to lower power. So this is how the linked list would be created and represented. So that part I am not going to do because we know how to create, except we have to read the two values here. So coefficient and power when you read. So this is here. So we are going to check starting from here, P1, P2. So which has got the, either powers are equal, we will add. Now the pointers are on the first, both powers are not equal, so the higher one is taken. So 2 is copied to the resultant polynomial, 2 and 4. Then this advances, because I have copied from here. So what happens, this polynomial, this advances to the next one. So this advances to the next. So now P1 pointer comes here, again compare this and here, because this has not advanced. So 2 and 3, 3 is smaller, so this is copied, 4 and 3, and now this will advance, come here. Now what happens, the polynomials are equal, the powers are equal, P1's power and P2's power are equal. So what happened, the coefficients get added, so these two are added, 5 plus 2, 7, and 2, the power is not added, power is kept as it is, either of the power, so 2 is taken. Then in this case both will advance. Okay, and here too the coefficients, powers are equal, 1 1, so these two are added, minus 3 plus 3 you'll get 0. So which means that term need not be created. Now we will see little later how to take care of it when we come to the programming part. So in order to do that, we will use a variable, I'll explain. So this term need not be, so here again both will advance, both advances. Here again I told you this is not 4, sorry, this is 0, powers are equal, then 2 are added and 3. Okay. So that is how. Now let us see how we are going to, so how we, it's almost like the merging. I think the once the list is there, it will proceed. Now let us see how we take care of the case of, let's see, these two polynomial and this resultant. Now how will we take care of this condition of resultant list becoming term becoming 0. So what we are going to do is we are going to use each time a temporary variable integer, new coefficient, new power. So every time we are getting the value here, for example, we are going to check if the value of new coefficient or addition, or if you are adding or getting the value if the power is high. For example, here the value came here straight, here value came here straight, here the value got added together. No, for example, now these two added together. So when there is an addition or when there is a value coming, I'm going to put into a new variable called new coefficient and new power. Only if new coefficient is not 0 will I copy it. So in this case 3 plus minus 3 0, so it is going to be 0, so it is not going to be created. That is how I am going to get rid of that part. I hope it's clear. So we will see the program, how the thing is done. It is almost like a merging. The possibilities are there, first time, the remaining. Then we have the cases of it is possible that one polynomial may have only one term, the other polynomial may have many terms, and when one gets over, the other one is not over. What to do? We have seen it in merging of two lists, and the same process will continue here too. Anyway, let us go to the program. I will attach this file, and we should be able to see the so here is a structure that is required, power, coefficient. Next, of course, I've used word node. Then we have functions, one to create, another function to add, which it takes two polynomials and returns a polynomial. Then my printing. Then I have my get node, which we used to do. Okay, so I'm reading the P1, first polynomial, second polynomial. Then I'm printing the first polynomial, printing the second polynomial. Then this is my program that adds the two polynomial, adding the two polynomial, the function, and I have my print. This is my printing a stable polynomial. Then this is my creation. The only difference is when I create here, I have to read for each node, just like before, 2. I'm reading the power and the coefficient. Okay. Be careful, even if the coefficient is 0, I have to read. Even the power is 0, I have to read the values both. Alright, let's go back behind. So this is a polynomial addition. Okay. This program, I think you do not have to explain because there's nothing like the merging. So first time t is kept to check if it is first time or remaining. So what we are going to do is, while p1, this polynomial 1 and polynomial 2 not equal to null, both have not entered, and if the powers are equal, okay, then what happens, the variable I said new power is going to get first one's power, coefficients are added, and both are advanced, p1 and p2 are advanced. Okay, but if p1 is greater, okay, here of course that means p2 is lesser, then new power is a first one's power, first one's coefficient, only first one is advanced. And reverse, when first one is bigger, then what happens, the second one is bigger, then new power is the power of the second one, no coefficient is second, and polynomial 2 is advanced. So now imagine what happens here. I'm copying. So if new coefficient not equal to 0, only if it is not 0, I need to create a term. So if it is not 0, I don't have, if it is 0, the term is not created. So if it's not 0, I create a new node. Power is the new power, the variable which I collected, new coefficient is then here I am checking if it is first time or remaining, which you are used to. So this is how the creation takes place, and the other conditions, if it is one polynomial ends or the other polynomial ends, and finally the sum is returned. I think this part should be clear. We always take care of the case first time, remaining, everything is explained. I think it should be clear. Thank you.